Welcome back to our series on the machine learning for beginners. Today, we're diving into one of the most popular types of machine learning, supervised learning. Supervised learning is a type of machine learning in which machines are trained using well-labeled training data. This means that the input data is already tagged with the correct output. The machine then uses this labeled data to predict the output. Think of it like a student learning from a teacher. Supervised learning can be used for a variety of real-world applications such as risk assessment, image classification, fraud detection, and spam filtering. So, how does supervised learning work? First, a model is trained using a labeled dataset. The model learns about each type of data in the dataset. Once the training process is complete, the model is tested using a test dataset, and it predicts the output. For example, let's say we have a dataset of different types of shapes that include squares, rectangles, triangles, and polygons. The first step is to train the model for each shape. If the shape has 4 equal sides, it's labeled as a square. If it has 3 sides, it's labeled as a triangle. And if it has 6 equal sides, it's labeled as a hexagon. After training, we test our model using a test dataset, and the task of the model is to identify the shape. The machine is already trained on all types of shapes, so when it finds a new shape, it classifies it based on the number of sides and predicts the output. There are several steps involved in supervised learning, including determining the type of training dataset, collecting labeled training data, splitting the dataset into training, test, and validation sets, determining the input features, and selecting a suitable algorithm. Supervised learning can also be divided into 2 types of problems: regression and classification. Regression algorithms are used for predicting continuous variables, such as weather forecasting and market trends. Some popular regression algorithms include linear regression, regression trees, and nonlinear regression. Classification algorithms, on the other hand, are used when the output variable is categorical, such as yes or no, male or female, or true or false. Some popular classification algorithms include spam filtering, random forest, decision trees, logistic regression, and support vector machines. Now let's talk about the advantages and disadvantages of supervised learning. One of the biggest advantages of supervised learning is that the model can predict the output based on prior experiences. This means that it can learn from past data and apply that knowledge to new situations. Another advantage is that we can have an exact idea about the classes of objects in the dataset. This makes it easier to train the model and achieve accurate results. Supervised learning models are also very useful for solving real-world problems such as fraud detection and spam filtering. However, there are also some disadvantages to supervised learning. One of the biggest disadvantages is that supervised learning models are not suitable for handling complex tasks. They may struggle with data that is not clearly labeled or that has a lot of variations. Another disadvantage is that supervised learning models cannot predict the correct output if the test data is different from the training dataset. This is because the model has only been trained on a specific set of data and may not be able to generalize to new situations. Additionally, training a supervised learning model can require a lot of computation time and resources. Overall, supervised learning is a powerful tool for solving many real-world problems, but it is important to keep in mind its limitations and when it may not be the best approach. Thanks for joining us in this video on supervised learning. Stay tuned for our next video in the series.